Hello, my name is Ardi and I will explain example 7.1 from Hambley's book. So the question is converting a decimal integer to binary number. So the question is convert the decimal integer 343 on base 10 to binary. Okay, I will present two ways to do this. The first thing that we need to know is we need to know the power of 2. Okay, maybe let's list some power of 2 here. 2 to the power of 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4, and so on. I just write it. 2 to the third power is 8, and 2 to the fourth power is 16. 2 to the fifth power is 32. 2 to the sixth power is 64. 2 to the seventh power is 128. 2 to the eighth power is 256. And 2 to the ninth power, that will be 512. Because this is already exceed 340, we just stop here. Okay, let's do that. So 343. Okay, first let's see the closest thing that is less than 343 but the power of 2. Here we have here like this, right? So we will have 256. Okay, so I will have 256 plus something. So I need to subtract this 343 with 256. I will not use calculator here, so I will calculate it manually. So let me know if I made any mistakes here. So we will have this one. This is 13 minus 6, that will be 7. And this will be 13 minus 5, that will be 8. And we will have 2 minus 2, so we will have 0. So I will have 87 here. 87. Okay, however, we are not done yet. Okay, now concentrate on 87 here. So let's write this as the closest things, that is power of 2 but less than 87. Let's do that. So I will have 256 plus, so this one is already exceed 87, so we will have this one here, right? So I will have 64 here. So let's do that. 64. But 87 is 64 plus 23, right? So I will have this number here. Again, let's do more here, but this time less than 23, which is, this is more than 23, this is less than 23. So 16 will be the next target. So we'll have 256 plus 64 and then plus 16. Okay, and then plus 7. Again, we treat this 7 like before. So 8 already exceed 7. So we use this 4 here. So we will have 256 plus 64 and then plus 16 and then plus 4 and then plus 3. Again, we have 3 here. The power of 2 that closest to the 3 is this one. So let's write it at. So I will have 256 plus 64 and then plus 16 and then plus 4 plus 2 and plus 1. 1 is already the power of 2, so we will have this one. Okay, so now we have the power of 2 all here. Okay, let's write that as power of 2. So we will have this 256 is 2 to the power of 8, but this is multiplied by 1. Okay, and then we will have 2 to the 7, which is 128, but we don't have it here, so I will have 0 multiplied by 2 to the 7 power. And then 64 is here, so I will have 1 multiplied by 2 to the 6 power. 32 is not available, so I will have 0 multiplied by 2 to the 5th power, and then we will have 16 here, so I will have 1 multiplied by 2 to the 4th power, and then plus, what is it, 8 is not here, so I will have 0 multiplied by 2 to the 3rd power, and then plus, what is it, 4 is here, so I will have 1 multiplied by 2 to the 2nd power, and then plus 0, oh, not 0, 2 is here, so I will have 1 multiplied by 2 to the 1, and then plus 1 multiplied by 2 to the 0. Okay, so what we need to do is just write this one, 1 0 1 0 1 0 1 1 and 1. So the final binary representation of 343 is 1 0 1 and then 0 and then 1 and then 0 1 1 1. This one all there, right? And the base will be 2. Okay, and this is the final number. Okay, this is the first method. Okay, now let's do the second method. Okay, let me clean the slide first. Okay, now let me present the second method, which is the question method, question or reminder method, whatever you call it. So we will have 343 here, 343. Okay, and we write a table here which is quotients and remainder. Okay, the first thing that we need to do is we divide 343 by 2. So what is 343 divided by 2? That will be 171, right? I think 171. 171. But we have a remainder of 1, right? Because remember, 343 divided by 2 is 171.5, right? So we have a remainder there. So the remainder is, okay, now let's put this 171 here and repeat the process. So we'll have 171 divided by 2. Okay, I think we will have 85. Yeah, 85. I think 85, right? Because 85 multiplied by 2 is 170. So we will have the remainder of, okay, and we repeat again, 85, put it here, divided by 2. Okay, 85 divided by 2, that will be 42, right? So we have 42. But we have remainder of 1. Okay, now put it here, 42 divided by 2. We will have 21, but this time there is no remainder, so I'll have 0 here. Okay, now I will have 21 here, so I will have 21, and we need to divide it by 2. Okay, and I think the answer is 10, because 10 multiplied by 2 is 20. We have 1 as the remainder here. Okay, now let's put this 10 here and divide it by 2. 10 divided by 2, that will be 5, but there is no remainder because 5 multiplied by 2 is exactly 10. Okay, now let's do this again. 5 divided by 2, the quotient will be 2 because 5 divided by 2 is 2, but we have remainder of 1. Okay, and now let's do again. I will have 2 here divided by 2. We will have the quotient of 1 but with no remainder. Okay, and now let's do 1 here divided by 2. Okay, 1 divided by 2, we will have 0 but a remainder of. Okay, now we get the remainder here and we read it from bottom to up like that. So we will have 343 base 10. Let's write it from the bottom to the top. So I will have 1, 0 here, and then 1, and then 0. Okay, 1, 0, 1, 0, 1, 0. Okay, 1, 0, and then 1, 1, 1. Okay, I will have 1, and the base is 2. Okay, and this is the second method, which is actually the same as the first. Okay, and I think that's all for example 7.1. Hopefully this will help you learning the logical circuit. See you in the next video. Bye bye.